So next concept, kinetic energy of a rolling body. So let's consider a surface. On the surface there is a spherical ball which is placed on it. So that what will happen? It will roll and it will comes to these positions. Okay, it is going to come in this, right? Fine. So what is the velocity of the center particle? Only translational. But what about this particle, this position? Let's consider this position is A. Now at this position it will be at B. Now it will comes to C. Now it is making on complete half rotation, right? A to C. A to, let's consider A, and this is also A. This is the position A and this is the position A. It is coming, it's changing its position. How it is changing? Circular path, right? Rotation. So this will have, here it have linear velocity, it will have angular velocity. Okay, when it is rotating it will have angular velocity. When it is moving straight, linear velocity. That means it have both linear velocity as well as angular velocity, both it have. Okay, right. So from this, what about kinetic energy for translational? Linear means translational. What is the kinetic energy? Half m v square. What is for rotational? What is for rotational? So rotational equal to half I omega square. This is for rotational. Okay. Now, what is the total kinetic energy of rolling? The total kinetic energy of rolling is kinetic energy translational plus kinetic energy of rotational. Okay. What is the translational kinetic energy? Half m v square plus rotational half I omega square. So here this also will be written as half I is the moment of inertia. What is the formula for that? I equal to m k square with respect to gyration. So m k square into omega. Omega will be written as, already we know the relation between linear velocity and angular velocity, that is v equal to r omega. From this, omega equal to v by r. So it's a v by r whole square. So kinetic energy of rotation will be equal to half m k square into v square by r square. Okay, clear? So here kinetic energy of rotation will be written as half m v square of k square by r square. So k square by r square will be written as beta. So beta is a dimensionless quantity. Okay. So now I am going to replace that. Kinetic energy of rotation will be equal to half mv square beta. Okay. Now I am going to replace that here. So half mv square plus this total term is, this is the one, that is half m v square beta. So here if you will take half m v square comma, then what you will get? 1 plus beta. If beta is 0, then kinetic energy will be equal to half m v square. Okay, this is for rotational kinetic energy. Okay, clear? Right. So here this kinetic energy, rotational kinetic, rolling kinetic energy will be changes with respect to the position of the body. I mean diameter of the body, axis of the body. Okay, clear? It will be varies, and body to body it will be changes. Let's see for ring. For ring, what will be the kinetic energy? What is the basic formula for kinetic energy? Half m v square of half m v square of 1 plus beta. This is the kinetic energy formula, basic formula. So from this for ring, what it is? So for ring, what is the moment of inertia? M r square, that will be equal to m k square instead of gyration. M gets cancelled, then r then it is k square by r square. What will we call that as? Beta. Okay, clear? K square by r square, that is equal to 1. So for ring, beta will be equal to 1. Okay, so if we'll substitute that here, kinetic energy equal to half m v square of 1 plus 1. So it is 2 by 2 mv square. So 2 gets cancelled. Kinetic energy is mv square. Okay, Clear? For solid sphere, for solid sphere, for solid sphere, what will be the beta? Same. Moment of inertia is 2 by 5 m m r square will be equal to m k square, moment of gyration. So mm gets cancelled. So k square by r square equal to how much? 2 by 3. Okay, that means beta equal to 2 by 3. Okay, then you can substitute that. Then kinetic energy equal to half mv square of 1 plus 2 by 3. Then how it will be written as? So 3 plus 2, 5, 5 by 3, 3 to 6, 5 by 6 mv square. This is for kinetic energy of solid sphere. For disk, for disk, beta will be equal to 1 by 2. For hollow sphere, beta equal to how much? It is 2 by 3. Okay, clear? Check in this case something we done wrong here. It is 2 by 5 mr square. So it is 2 by 5 and it is 3, 2 by 5, 5 plus 2, 7 and it is 10. Okay, so it is 7 by 10 mv square. So this is the kinetic energy in this case. Okay, you substitute it properly. Okay, clear? Right? So this is for disk and this is for hollow sphere. Okay, got it? Next. So what is the fractional change in translational kinetic energy? Fractional change in translational kinetic energy. Fractional change in translational kinetic energy. So that fractional change in translational kinetic energy will be equal to 1 by 1 plus beta. Directly you can use this. Okay. So what is the fractional change in rotational kinetic energy? Rotational kinetic energy for fractional change, it is beta by 1 plus beta. Okay. And what is the ratio of these two? Ratio of these two is 1 is to beta. Okay, 1 by beta. Clear? Right. This is for fractional change in translational kinetic energy. This is the fractional change for rotational kinetic energy, and ratio of that both of that is 1 is to beta. Okay, clear? This is the total explanation for kinetic energy of a rolling body.